Hi everyone, good evening. Welcome back to the session. Hope everyone is doing good. As part of our session, we will be discussing about the applications of data science, machine learning, artificial intelligence in the space of HR domain. As we have seen yesterday, how these analytics will benefit the HR stream, HR domain. There are a lot of challenges that HR people will handle day-to-day activities in their day-to-day activities. And we also have seen the HRIS systems or HRMS systems, which are the de facto repositories or applications that are used by HR person or HR departments. And as we have seen, oh, sorry, my bad. So as we have seen the HRIS system, then we also have seen metrics. These are some of the metrics that HR people use to streamline the entire workforce for an organization. There are many such metrics which can be monitored, measured. And we did discuss about the system which can help the HR team to be easily identify these metrics and measure them. Anything that can be measured can also be managed, right? And these are some of the challenges where analytics is basically being used to overcome these challenges, crucial areas of HR. Then some of the very important insights that we can see here. These are the core areas where HR analytics is being implemented. And we've also understood that disengagement is one of the biggest problem area for HR teams from the employees' perspective. We need to ensure that the employees are engaged. The HR analytics stream is set to increase tremendously. There's a huge scope. It's a multi-billionaire billion market right now. By 2025, it is expected to grow to 3.6 billion USD. Now, how are we going to implement all this, right? So that is something that we need to understand. So we will be talking about the stages of analytics to begin with. Let me take you guys to that. Oops, sorry. Yeah. All right, any business problem that we are looking at, right? Any problem statement that we are trying to resolve. From a data perspective, right? If you look at the solutions that are being developed in the industry right now, majority of the solutions are developed around about data. Data holds the key. Okay, data is considered to be the new oil. And we HR people have a lot of data at our disposal, and we can use that power to streamline things. Whenever there is a problem statement or any situation that arises, we need to first understand what that problem is all about, right? What happened? That is very, very important. And this is also called as descriptive analytics, right? In the analytics terminology, this is called as descriptive analytics, right? So that is the first thing that we do. For example, there's an employee. He has some issue, right? And probably he's going to talk to his manager, his or her manager. Now, the manager is trying to resolve the issue. Manager has to first understand, or probably you put yourself in the place of manager. You are the HR person and the counseling is happening. One-to-one discussions are happening with an employee. Now, in this one-to-one discussions, you would try to ask certain questions to understand what is going on currently or what has gone, right? What has happened till now with respect to that employee. How was the experience, right? Any challenges that the employee was facing, etc., etc. This one will be basically on past. This is called as descriptive analytics. We generally talk about reports, summarize the things. Then we look at why this incident are happening. So if a manager, right, if an employee, for example, is having some concern, we'll try to understand that. And we have to try and investigate what is causing that issue. Okay. So that is diagnosis. So we are trying to do diagnostic analytics, which tells why something has happened or why something is happening. What is causing it? Right. So this one speaks about what, and the next layer is talking about why. Now, practically speaking, these two are merged together. They're generally merged together in a practical case. So we'll record things and then we will try to investigate and find out the root causes. We generally call it as root cause analysis. If you know, if you can identify, if you investigate and identify what is causing this particular problem, then you will be able to address that issue. Right? For that, we need to know, isn't it? What actually is causing the problem. Now, once you know what happened and why something is happening, the factors, then comes the predictive analytics, which is about estimating things for future. So we say what is likely to happen or what may happen in future. We know something happened and you know why it happened, right? So if you continue without changing, without altering any of the factors here, then what is going to be the future? Estimate the results upfront. Now we also know the factors, right, which are causing these issues. So why not we change these factors? Why not we address, right, or alter some of the factors, one of the factors or anything, some measures. If you can alter, then you will be able to learn on what could happen if you're altering a specific value or a specific factor. This experimentation will give you a very good insight in order to take an appropriate decision. Right? You'll be able to take a proper decision because now you have evidence, mathematical evidences, which can help you estimate the results upfront. Right? So that is called as predictive analytics. All we do here is try to convert a regular problem that we have, right? Day-to-day problems that we are having onto mathematical models. We construct a mathematical model. Okay. For example, an employee is going to resign, right? So when one-to-one discussion happens with HR, probably the employee is expressing his displeasure, some concerns. So HR records these concerns and then investigation happens and we know factors which are causing the issue. Why the employee is not happy, the satisfaction score. So what factors are actually demotivating this employee? Now, when we know the factors, for example, we are talking about the number of hours that the employee is working hours. And the another biggest problem that we look at is compensation. So these are the two key areas which employees having concerns with, right? So we say, try to replace, try to bring in this data points into a mathematical expression, right? Say, for example, you are going to increase the salary based on the working hours, right? So we try to establish that relationship, and here we will call it as y is equals to f of x. This is a very, very simple representation of a mathematical equation, right? So y is equals to f of x. This f is the function which explains the relationship between the input factors and the output that we are interested in. So we want to know what should be the compensation, what should be the salary that the employee should get, depending on the number of working hours. There might be other factors also. I'm just explaining it on one factor. If the number of working hours is increasing, obviously the compensation should increase. But is it increasing? Is it not increasing? These are the kind of factor analysis right, operations that we try to do. And once we establish a mathematical equation which can generalize for every employee in the organization, we use this equation to ensure that the employee is getting paid according to the industry standards. So this is your predictive analytics. We are upfront predicting on what could be the salary, given the bunch of factors. Now, once we do this, right, once we come to know what is this equation, and once we are trying to do the predictions, right, we know what is going to happen in future, right, expected, what may we expect that, right, which could happen in the future. So when we look at all this, we will come to know what solutions will work and what solutions will not work. As an expert, as a subject matter expert, as a HR personnel, you would be able to guide the right team or guide the solution in finding out the appropriate factor which could actually resolve this problem. Right? So SMEs will be able to give you solution. If you are a subject matter expert, then nothing like it. You know all these capabilities and you also know what solution will work. So you are going to do the right appropriate, the exact or appropriate experiments, which can solve the problem quickly. Okay, so these are the 4 stages. Very common scenario, doctor and patient example you can think of. Right? If the HR personnel is the doctor, the employee is the patient. At the first discussion, the employee, that is a patient, is going to explain the conditions, right, to the doctor, that is to the HR. Then doctor basically tries to find out why those issues are happening, right? So diagnostic tests will be prescribed to the patient so that some tests can be done and the reports are being analyzed. Same way, HR people will try to investigate to understand what issues, why that issue is occurring. When we're talking about predictive analytics, what is likely to happen? Here we are basically looking at doctor, right, as upfront telling the patient, saying that, hey, if you're not getting treated, then this might lead to COVID, for example, just as an example. Okay. Same way, here, HR will be able to understand that employee might resign, for example, right? Or employee might escalate it to the higher management that some concerns are not being addressed. So you'll be able to predict that upfront. And before that happens, you might want to give a solution. I understand the problem and then address that problem. So that is your prescriptive analytics. Now, remember one thing, these are always in stages wise, right? One after the other. You cannot directly jump into the final stage. We'll have to go step by step. Okay, these are the 4 stages of analytics. Now, you all know about descriptive analytics and diagnostic analytics, which are pretty common in the industry, right? I mean, every organization does this. In fact, you are also probably using a system which gives you these solutions, right? Reports, a lot of reports, and you'll also be able to highlight why those issues are occurring and etc. Those things. Now, as part of this intro session that we are conducting here, right, the HR analytics domain specialist sessions that we're talking about, we will see how predictive analytics can be used in solving a lot of business problems. Okay, and here we will use machine learning. Machine learning will also have descriptive analytics strategies. It's not just predictive analytics, but it also has descriptive analytics strategies. So we are going to learn about these things as part of the program. Now, because you're a subject matter expert, once you see the results, you will be in a good position to comment on what needs to be done, what not needs to be, what should not be done, and all that, based on the experience that you have in the segment. But this comes only after, obviously, you see the results from predictive analytics stage. Next, from a more technical perspective, right? Let me give you a quick overview on what exactly is machine learning. You probably are familiar with traditional programming, right? I mean, we talk about programming, very simple programming. Maybe you have a lot of employees who are in the IT department, they're developing some softwares and all that. So programming, a typical programming life cycle, right, is not similar to what we are going to do in ML programming. These two are two different worlds. Okay, it is not the same. So all these years before data analytics, machine learning came into the picture, the application developments were there. And in that case, we used to do the traditional program. So the difference, right, we'll try and compare traditional programming versus machine learning. In a traditional program, a developer is required to take the data and write a program on top of it. So if I give HRS data, employees database, for example, then the HR or the developer, for example, should be able to write a logic by consulting the HR people. And once the program is ready, we will use a machine to execute that program on this data. And this is going to give us the output. This is a typical programming flow, programming life cycle. Or you can say software development, right? So this is what happens. But as I said, machine learning is completely different from this. Machine learning, a machine has to learn things. So how does it learn? It looks into the historical data. Historical data means old data, the data which is already, the event for which the data that we are collecting here, the event has already occurred. Right? So in this data, because it is historical, we will know what is the input that you have passed and what did you expect as an output. Right? You'll come to know that. So input and output, both the things are there. Now, when you pass input and output to your machine, the expectation is that the machine, the computer, will figure out the program, or we call it as function, or we can also call it as the relationship. Right? This relationship is nothing but the pattern in the data, the specific pattern, right? So we're trying to capture that. All right. So function and relationship. Now, in order to come up with this function or relationship, a mathematical equation for that matter, we will try and use this input data and output data. And this is where your computer will be able to explain the relation between input and output. All right, so that is basically your machine learning workflow. It is completely different from your traditional programming. Now, whenever we try to utilize data, right? Remember, data contains a lot of information in it. That is nothing but some kind of a hidden pattern. If you are able to capture that pattern, then you'll be able to understand the information that is hidden in the data. Now, if this information is upfront known to you, I mean, if you are getting the information upfront, right, then you'll be able to take a better decisions in a given scenario. It will enhance your knowledge, basically, right? The information will enhance your knowledge. And from this knowledge, you'll become wise. So you'll get the wisdom. So this is a wisdom pyramid. You can look at the pyramid. And we are somewhere here. Okay. So every data will contain information. We need to extract that information. Okay. Next. This is a product that we have developed. I'll just quickly walk you through with that. And then we'll move on to discuss about the machine learning primer, the data science primer. So as part of the product, right, we developed this product. But before I go to explain what is the product all about, there's some of the stats that you need to understand here. When an organization is trying to hire some resource, right? The organization calls in for resources. So HR personnel will become the pivotal, right? I mean, they become very pivotal here. They hold a very pivotal position because these people profiles that we receive, right? These people have to be filtered, and HR will be able to do it, right? And for filtering, right? What we mean is when a job description is given, when an organization is looking out for a specific job, I mean, to fill up a specific job, then we need the candidates who map to that, who match to that requirements. The skill set should be similar. So HR personnel will manually evaluate each and every resume, right, and try to match the requirements, right? And the stat says that according to a study, the Ladders, that's the organization which released a study, an online job matching service, recruiters spend an average of 6 seconds reviewing an individual resume. Okay, that's the least, 6 seconds. And there is this another portal, the undercover recruiter, and it has an average of, assume, an average of 250 resumes are received, right, for a job application. So this organization, in fact, has received 250 resumes on an average for each job application that they try to publish. This is a consulting firm, right? So they generally keep publishing these details and they'll get the reports. So what is happening here? The traditional approach, job description will be there, the resume will be there, and we are trying to take 6 seconds to do the comparison. Now, if I include this for many resumes, 100 resumes, so I will have to spend 600 seconds, right? Because here we are saying 6 to 10 seconds, I'm taking the least, and when your right number of resumes increase, the time delay also increases. And yeah, this probably will take 10 to 15 minutes. If I take 100 resumes, it will take 10 to 15 minutes. Similarly, we will be doing it for many such requirements, many such 250 messages, and a lot of profiles are also coming towards us. So if I have to do this mapping, then manually it is going to take a lot of effort, right? So what we have done is tried to automate, right, the mapping process. So here we used, this is just a stats, the traditional approach. Over 20 job descriptions were taken, and 5,000 resumes were shortlisted, were considered. Now, if I have to process these 5,000 resumes, it will take around 25 business hours. So it's like that Matrix movie. We want to automate this mapping process so that we can directly go to the resume which meets the requirements. Right? So this is done using NLP technique. Okay, ideally it is 25 to 35 business days, which is now reduced to 25 to 35 minutes, days to minutes. And this is the portal that you will see. It's like our first portal that you will be seeing. So we have the portal. This development was done. The development that we are looking at here, right, it is done using Flask application. We'll be talking about that. But as the resume you want to get for a specific job description, we will take the key areas. What is the job ID? Right? What features we want to select? Then we will say the resume ID and what content you want to share. So it per page it shows only 10 entries, and it is saying that there is no outcome. So this page, right, what does it do is it looks into the repository of all the resumes. It could be tens and thousands of repository emails. It scrapes through each and every message and identifies, right, which message has the maximum mapping, maximum similarities. And based on the similarity scores, we will arrange them in this decreasing order. Okay, so this is basically one of the softwares that we have created some time back. A lot of additional features can also be included in it. But yeah, this is just a quick overview that I wanted to share. Now let us try and understand what is machine learning primer, or what is data mining in the first place. We're talking about analytics, right? So we will have to churn the data, right? We have to mine the data. So that is nothing but data mining topic. The data mining speaks about two broad approaches. One is supervised learning, the other one is unsupervised learning. Okay, and we basically try to churn the data so that we can get some insights. So we will be talking about the difference between supervised and unsupervised. We'll be talking about machine learning primer. We will be talking about something called as data split, and how do we evaluate the model. And while you are evaluating, you also have to care for that overfitting and underfitting problems that we might arise. So this is the unsupervised learning technique. So in the data, in the machine learning, we have when you do unsupervised learning, we do not have a label. Okay, we don't have labeled data. That means I'll have only X, right? This X, I don't have Y. So when you're trying to establish the relationship, you'll only look at X because there is no Y, right? So you only look into X and then try to establish relation between, right, different X variables, different records. Okay. Because we don't have Y, we don't have any supervision. Hence, they are called as unsupervised learning techniques. And if you look at the process, the unsupervised learning technique, the process is that we'll have training data. The training data is taken into right, historical data. And then we have tried to build the model. Right? And then we'll have Apache related services. So if you apply any strategy, you get rules or patterns here. Now, using those rules and patterns, when you get new data, there's no splitting required yet. When you get new data, we will try and utilize these solutions, right? And then try to identify the outcome of new data points. So very, very similar, right? Flow diagram. This is for your unsupervised learning. Then comes supervised learning, and this is a little tricky. We'll try and understand this. The supervised learning, as the name suggests, it will have output variable also in the data set. That means you will have a data set with X variables. This is your input. It will also include Y. Right? It is also including output variable Y. All right. Now, when you're trying to establish the relationship between input and output on a mathematical front, Y is equals to F of X, this mathematical equation can be used for doing predictions. But if I have to consume this equation, you need to ensure that the existing, because the historical data records are actually being predicted or predicted with appropriate accuracy or not. So we will be trying to develop a machine learning model on supervised, on this data set, and this is called as supervised learning, where we try to use the output variable for identifying the pattern. So under the supervision of output variable, the we can say that the training of the model happens. Okay. Now, in order to say that, hey, this model is a good model, we need to evaluate it. But evaluation process is happening by taking this approach. So what it is doing is it is trying to take the data, this is your historical data, and split that. Right? And this splitting happens randomly. We ensure that the training data set is at least greater than or equal to test data set or validation data set. At least it has to be similar. Now, this validation data set that we are getting, if I have 100 employees, for example, I'll have to work on the 100 employees data. Then we will try and take maybe only 80 employees data. And we will use this 20 employees data for validation. So it is like hidden. Okay, it's completely hidden. So whatever the algorithms that you're using from machine learning, side of things, we will ensure that we get an equation. There's some mathematical equation is something that we'll be able to get. Now this model that we have developed here, y is equals to f of x model that we have built here, has to be evaluated also. So how will it work? I mean, I'm training a student, or I'm training a new joinee. Okay, a fresher who has joined in the HR team. He is not aware of a lot of things. So we're training them. Okay. But when the training is completed, we also might want to evaluate whether the student has actually learned something, right? So to do that, we bring in this validation data set, which is completely hidden. Now, using this model, we'll try to do the prediction. Right? So whatever the equation that we got here, that same equation will be used here. Right? On the validation data set. In validation data set also, we will have x and y. So we will hide this and we'll only pass x data. Okay. Now, once the x data is passed, it will calculate y. Okay. When you talk about y, we also know the predicted result. Just now we predicted. We will take the predicted result and compare it with this y, which is hidden. Right? We are hiding it. So when you do the difference, we will get error. Okay. So we are basically getting error here. Right? And using this error only, we will try to choose the best model among the various experimentations that we are trying to do. Okay, so that is about the simple workflow. Now, once we have decided what is the mathematical equation that is selected or finalized, we will try to use the same mathematical model or mathematical equation here. So this is the validation that I spoke about on the training data set itself. But in order to generalize it, we will take validation data and then do the assessment. So if an unknown data is given to this particular model, then how does it work? Okay, that is measured. And once you have done your best model choice, we will try and merge again everything. Training data set and validation data set, right? We'll combine both of them. And then we apply the same model once again to make it ready and use that model, the final model, in predicting, working with new data while you're working with new data. So when new data is given, the model that we have finally chosen, right? This model will be used for predicting the results. This will give us the predicted results y hat. All right. Now, when we are trying to do this prediction, friends, very interesting point is what is that you are trying to capture? Are you trying to capture a numeric value or non-numeric value? What is that you are trying to measure or predict? This is very important. And based on this, the models are segregated into regressors and classifiers. Right, so we'll have regressors and classifiers. If the output is, okay, let me talk about this. If the output is non-numeric, then we cannot do a mathematical calculation, isn't it? So if you're saying, will an employee resign? Okay, the employee has resigned, or let's say absent, right? Then whatever you are predicting, let's say this is the absenteeism that you're predicting. You'll say present or not present, or absent, you can say present or absent in short. Right? And what happens is, if you are predicting for an employee that the employee would be present, then the actual case either could be absent or present. Right? The actual value could be either of these. If you predicted as y hat, and the actual value is like p only, regular values, right? Then when you do the comparison, we'll say that this is dissimilar, whereas this one is similar. So what we do is we'll compare. When you do the comparison, you will get false and true. Right? If both are saying that the employee or the HR personnel is able to identify that the employee is resigning, then that means yes, we can let that employee go. That's the correct prediction. All right. So if you look at this table, we are going to put, right, let's say absenteeism. And if you're predicting with absenteeism, it could be, again, this absenteeism, and then this could be right, the present. So 4 quadrants is what we will get. 4 values is what we get. This arrangement that you're seeing is called as confusion matrix. Now, if I say this is the actual values and these are predicted values, the correct predictions that we are making are called as true positive cases. Correct predictions. Okay, this is called as true positive because the comparison is true. Right, and what we are predicting that the employee will be absent, assume. And if the employee is actually absent, then this is true positive. The same way, if there is, let's say, a patient who is, a patient, right? So, or an employee, if let's say resigns, if they say the employee is applying for a leave. But when we assess the requirements, when we got through the requirements, we found that the actual case says that these are positive cases, right? That means the employee was present. But what are we saying here? Negative. That means the employee was not present. Okay, so negative. This is positive, this is negative. So the negative value that we have predicted, which says that false negative, is wrong. Right? So this is called as false negative because you are predicting that the employee would be absent. But ideally, what happens? Present is the employee is actually present on that day. Now we will just flip these cases. We will say employee absent. That means employee is actually absent on that particular day, right? And you may say that no, the employee is present. So this is a wrong prediction. Okay, false negatives and false positives. And finally, we have the this is present and this is absent case, right? So we will have this is not present. And of course, your diagnostic, right? I mean, your tests that you're doing will also yield that this is true negative. True negative, as I said, is about correct prediction. So true is talking about correct predictions. What is that prediction? Here you predicted it as positive. Here you predicted it as negative. These are correct matches. We also have mismatches. Mismatches is all about error classification. So true positives, true negatives, false positives, and false negatives. We can basically use them. That's a terminology. Now, to get the accuracy, we will have to take the true values. Right? True positive plus true negative by total. Same way, the error can be captured by using this false values. False positive and false negative. So this gives us the overall error for your model that we are coming up with. Now, what if the value that you are trying to predict, right, is numeric? If the output value that you are trying to predict is numeric, what compensation should we give to the employee given the bunch of benefits or bunch of features that we have? So this is the value that you might want to predict. Okay. So if you see, this is your actual data. And this is model 1. Some mathematical model we have developed, and it is trying to capture the compensation, salary. The actual salary is, let's say 100. And when we predicted the value using the model 1, we get 1 out of it. Similarly, here 199, here 301 and 39. So it's a classical example of the deviation for your predictions. Right? That means this model that we have used is displaying these errors. 1 minus 1, 1 minus 1. Then we have the second model. On the same data set, we are applying another model. And now what we observe here, the values are little high. So what this is 100 and this is 1. So the difference is there. So what we are looking at is model 1 and model 2 performance. If you have to analyze, by looking at the error, mean error, it will be 0. It will be, performance will be constant, right? Same. But if you look at the individual values, right, individual numbers here, you can clearly see that the deviation in model 2 is huge. Ideally, we wanted to predict the value as 100. But in model 2, we got 110. Whereas model 1, we got the predicted value as 101. So obviously, the model 1 is giving us quicker results, right? Or much closer errors. So that means, the model 1 is a good model because overall the deviation is less, and it has helped us to reduce the deviation in the predictions. So model 1 will be preferred, but the strange point is we cannot directly calculate each and every value like this and compare. Right? So we need an estimate, right, which can use any of these formulas to measure the errors. Mean error is always going to be 0. Okay, very important point. We'll have to remember that the mean error that you are going to get, right, after you do calculation on errors will always be equal to 0. This is right, very important point. It will always be equal to 0. So to overcome this problem, because see what happens is if you have data, right, you're coming up with some equation and your data could be above or below. Right, so when you do these differences, the values get evened out. So mean error will always be equal to 0. Okay, and as you have seen positive or negative numbers, to remove the negative numbers, right, it will always be summation of positive and negative will be equal to 0. So we are removing the negative values. We only want to consider the magnitude and not the direction. So we can use MAD, that is mean absolute solution. We can use mean squared error, or we have RMSE, which is another very popular measure for metrics. Any model that we can look at, if it is output is numeric, then we try to develop these models, and we'll try to use this calculation for doing the assessment. We also have mean percentage error and mean absolute percentage error. These errors will give us the results in percentage form. Okay, they are going to give us the result in percentage form. Right? So this way we tend to use the different formulas to assess, to measure the performance of a supervised learning model. Okay, so once again, let me just quickly revise things. I'll take this slide. We are trying to understand the machine learning workflow. Right? This is nothing but analytics. Okay? We are trying to do data analytics, and to implement that, we are using ML workflow. So in the ML workflow, we have the data mining concepts that we are trying to brush up here. Right? We are brushing up our skills with respect to data mining. The data mining is actually broadly split into unsupervised approach and supervised approach. Okay. Now here we do descriptive analytics, whereas here we do predictive analytics. Descriptive and predictive. All right. Now, when you do these predictions, it is all about converting the business problem into a mathematical expression. And your supervised learning techniques are all about identifying this function, which explains the relationship between y and x. Cause and effect relationship. Now, when we're trying to use this model, mathematical model, we need to know that this equation is actually appropriate. Right? So for that, we use trained data, right? And then we'll substitute x into the equation, and we will see whether we are getting y or not. Okay, this is on the training data set. And when we talk about this x and y, we need to be careful with what algorithm you're going to apply. We may choose one of the regressors, or we may choose one of the classifiers. It depends on your output variable. If it is numeric, right, then we will go for regressor models. And if the data is non-numeric, then we go for classifiers, numeric and non-numeric. Now, when the values are numeric, we will be doing the difference which is nothing but the error. But we need an aggregated error for all the data points in the data center in your trained data, right? So what we do, we take each and every record's error and then do the aggregation. The aggregation will always be equal to 0. Right? The error will not be equal to 0. That means y and y hat, right? These two are basically different is what we are trying to explain here. This is actual, this is predicted. So how deviated we are from the actual values what we are getting, and this difference is nothing but your errors. So we take average of all these errors, and the average of errors is always equal to 0. Hence, we look at right. Let me write this. So average error is equals to 0. So that means the model that we have given is the best model. Error is less. That means this is the model which needs to be finally selected because there is no error at all. But if the data is non-numeric, okay, so here we are basically discussing about errors, and we calculate RMSE as the most popular right value, and then we'll also use maybe. Okay, RMSE and maybe. Now, when we talk about non-numeric output, we are going to use something called as confusion matrix. Okay, it's a 2x2 comparison chart, or we can call it as pivot chart or descript chart or summary chart, right, which can summarize the results for us. All right, so this is your non-numeric data. For doing the assessment, we use confusion matrix. So these are the ways we will use for assessing the model's output. All right, so that's basically your data science primer, or you can say machine learning primer. Now, in next class, that is tomorrow, we will be starting to understand the predictive analytics. And you will see that it is very, very easy to build a very simple predictive model. It will be a good quick start for you people to start your journey into analytics. Okay, I'll take a small data set and I'll see how the problem area can be solved using machine learning techniques. So do join me. Do join 360DigiTMG to join us. And we will be discussing some interesting stuff with respect to HR analytics. Until then, see you all and take care, everyone. Good evening.